we could have directly checked it. No, something like a it undergoes alpha decay. Let's assume that one. What is this FR? 87, huh? It will come francium. I'll write name, unable to pronounce. Francium, CRUM. Okay, no. Now, like this actinium, will it undergo alpha decay to produce francium daughter nucleus? If I give the atomic mass unit of actinium, francium, then work out Q. If Q positive, S on its own, it will undergo alpha decay. No need of any help. The element itself can undergo alpha decay. These are very popular. You check the advanced, they may just give some reactions. They'll give atomic mass unit. They'll just ask you possible, this reaction is possible or not, means on its own. On its own, this reaction will occur or not. So you go back to chemistry, reaction will take place or not, who will judge? There's a method. See, nuclear physics is a very fundamental one. I'm telling this one is a very fundamental for the chemistry here. You should have, since you have to study so many things, you'll study at the end, but nuclear chemistry is something very essential. A given reaction will take place or not. I got Q positive, so as reaction will permit, as alpha decay possible. Next year, this actinium will get converted into thorium. So this one, beta minus decay. I got Q positive, so yes, it is possible. Now look at this. Like if it like actinium, if it converts into radium, beta positive, beta plus decay, I got Q negative, so it will not undergo beta plus decay. Next is we are bringing electron capture also. Okay, there's a neutrino. It should be like this. Here also electron capture possible for this particular thing is you have to just take the mass of actinium, mass of radium, take the difference. If that Q is positive, okay, fine. If that Q is positive, electron capture is allowed. If Q is negative, electron capture is not allowed. Means like what are the things what we have? Alpha decay, beta decay, electron capture, fission, fusion. All these reactions, will they occur or not? Will determine the value of Q. I'm just setting up the background for exothermic endothermic reactions, what we are going to start after a few more problems. The exothermic endothermic is what we are going to learn now. There this idea will come. Sir, okay, still I want the reaction beta plus 2. I want this actinium to undergo beta plus decay. What shall I do? You can initiate a reaction by supplying energy. This will undergo reaction on their own. Alpha decay, beta minus decay, electron K capture. Beta plus decay not possible for the actinium. But can we make it to undergo? Yes, by supplying the required energy. So therefore shall we call these are like an exothermic reaction. This is endothermic reaction. The word of exothermic, Q positive called as exothermic reaction. This also a possibility of asking you, they'll give the set of reactions, they'll give the AMUs, the data. Here they will classify exothermic, endothermic, alpha decay possible, beta decay possible, everything. So the one Q positive you call exothermic, Q negative is endothermic. This is a very important part of the discussion, the nuclear physics. The data is missing. You should have given the mass of the actinium, francium, then radon. This one, if he has given all this thorium, then we could have ourselves checked all these things. Okay. So reaction possible or not? So what is the judgment? How do we can judge from Q positive or Q negative? How to calculate Q positive or negative? Mass of parent minus mass of daughters. If they give binding energy, mass of daughter minus mass of binding energy of daughter minus binding energy of parent. If binding energy of daughter more than that of binding energy of parent, then reaction is possible. Okay, fine. Either way, most of the things will be given in terms of the mass of parent daughters only. Sometimes what happens, they give binding energy of daughters, binding energy of parents. In that case, if binding energy of daughter more than that of parent, reaction is possible. Already I think yesterday we made that rule. Sometimes they may confuse you. Instead of giving mass, they give binding energy also. Just be alert. Now